Okay everyone, welcome back to CAD That Works. In my last video, I reverse engineered a failed lever arm on a broken food vacuum sealer. So in that video, we looked at the geometry of the broken part, how it basically functions, and we documented the critical dimensions. So in this video, we'll be jumping into Onshape to start designing a replacement part. Ideally one that's not only functional, but a little more durable than the original. So I'm going to walk you through how I think about sketching this from scratch, how I chose my design constraints, and how I'm going to design it for strength and ideally fit, and lastly 3D printing, because there is some nuance to designing something for 3D printing depending on the method you're going to be using. So as a reminder, this is part 2 of a 3-part mini-series, so if you missed the first video, check out part 1, and then stay tuned for the next video where I will be 3D printing this part we designed and testing it live. All right, so let's dive in and go ahead and start modeling. So this is not a basic tutorial on how to use Onshape, but I assume you have some basic knowledge of it. But even if not, I'm going to keep it simple enough where anybody should be able to follow along and create the same part or something similar. So you open up your Onshape. You go up to Create, Document, call it Vacuum Sealer Fix. Create public document. It's going to load our workspace. And the first part of this, what we're interfacing to the food sealer is basically a keyed shaft. Hollow cylinder with some keyways. It's going to interface to that, and that's going to allow you to turn the lever arm, which is going to open and close a little door on the vacuum sealer that helps seal the food bags. So step 1 here, I'm going to go up to Sketch. We're going to create that first shaft with the keyways. Sketch. I'm going to select my top plane. Left click. I can go up here. You don't have to orient it like this. This makes it a little easier to see. You can go up here and just click on top. There you go. We're going to go to circle. You can also just hit the button C, which is a little faster. It opens that command up. And what's nice about Onshape is it kind of tells you the hotkeys right next to the command. So circle C, arc is A. So anyway, go here and just go ahead and select that little dot there in the center. It goes yellow. Drag your circle out. Now we're going to dimension this based off what we found in the first video. So that outer diameter is going to be 10.78 millimeters. So let's just do 10. It's in inches right now, so we're going to have to change our workspace units, which is another thing. It kind of typically defaults to inches, but we can change that pretty easy. You go up here to these 3 lines, select that, workspace units, millimeters. Hit that green check. Now everything's going to be in millimeters. Now what that did, I did that, I hit 10 on some dimension there. Now it's converted that, so it's going to be, 254. So I can hit the letter D, dimension. Oh, sorry, got to go back, open that sketch up, edit it, right click, edit. There we go. So see, converted that 10 to millimeters. So really what we need that outer diameter to be is 10.78 millimeters. All right, there we go. Let's go ahead and complete that sketch. Next thing we're going to do is extrude. So you hit extrude, click on your sketch. Depth is how tall it's going to be. Let's do 13.93, that's what I measured. Hit enter, green check, and there we go. We've created a nice little cylinder. So now we could have also used the revolve command. I'll get into that maybe on a different video. I think for a basic video, this is maybe a little simpler to do it this way. So let's go ahead and create that inner diameter on that cylinder. So hit sketch again, and we'll select that top surface. And you notice I don't have to orient it to the top. I can just hit, go up, hit my circle, and it will kind of snap to that center. Do that. All right. Now hit the letter D for dimension. Click that left click again, and that inner diameter is 6.29. All right. Now, because the depth of our keyways is the same as the inner diameter, we're going to go ahead and sketch our keyways at the same time. So this time I will go up here, click top, orient it as such. All right, so for my keyways, just going to hover over that inner circle, left click, and you can see when it gets vertical or horizontal, it gets kind of like a yellow-blue dash line. It goes snapping vertical or horizontal, so that makes it nice and easy. So it doesn't really matter dimensions right now. It gives you a number there. Just do whatever, bring it over, click again. Okay, now I need an arc to go from here to here. So, I like to use center point arc on things like this because I know the center point. It's easy to get to. It's right here. Left click, bring it up, hover over that vertice right there, left click, drag it over, left click again. Now you can see it's not centered on that horizontal plane there. So how we fix that is we go up here to symmetric, left click there, left click here, and then click that center line. There you go. Okay, so let's go ahead and dimension that groove as we measured in the first video. That groove width is 2.5 millimeters. The height of that groove is about 1 millimeter. Now, if the keyways were the same, I could just do a mirror about this plane and it would do the same exact geometry on this side, but they're not the same. So we're going to have to just draw that the same way we did the top one. Select your line, circle, left click, drag it over, left click again. We'll do our arc again, center point arc, select the center. There we go, there. Hit the letter D for dimension. Let's go ahead and dimension that width. It was 1.8 millimeters. Let's do symmetric again. Left click, center plane. Okay. So here we go. Let's get that height of the groove. It was about 0.78 millimeters. All right, so right now we do not have a good sketch because you can basically have two different sections. So what we need to do is go up and trim because we have this outer circle or the inner diameter of the cylinder and we have the keyway. So we just need to use a trim. We're going to hold down our left mouse button and drag it across what we want to trim. There we go. So now we've got a nice sketch. And now, if I complete that, you can see there's my sketch, sketch number 2. So then we're going to go to extrude, click that, and this time we're going to hit remove. Select the sketch that we just try and remove. Okay, and now we set the depth was 11.66 millimeters. And you can see it goes down into that cylinder, but not all the way through. So there we go. That's kind of our critical keyed shaft that's going to interface with the vacuum food. So obviously it's not done because we need something to be able to turn it by hand. And also we need a little screw hole there. So sketch again. We're going to select that inner surface. Circle again. Let's do top. Make sure we're getting it right there. Okay. D, let's do the diameter. Let's do 2.5 millimeters. Okay. Hit extrude. Select sketch. Hit remove. Sketch 3. This one we're just going to go through all because nothing behind it right now, so we can do that command. Your other options are blind is where you set the depth. Up to next, I could use that too. I could use up to face and select that bottom face. and all those would work, but we're just going to do through all. Select. Okay, there we go. So we've got a keyed shaft, or a key shaft way that's going to fit on a keyed shaft on the vacuum sealer. But now we just need some way to turn it. So, one thing I haven't mentioned is looking at this is easily 3D printable. So, the bottom surface here would be in the print bed. No support material is needed this time, and just print it bottom and top there. But we'll get into that on the third video a little bit more about some of those design decisions. Let's go ahead and add a chamfer here, a little small chamfer, just to kind of aid in assembly when you're sticking it on there. Doesn't get caught up on any edges. Okay, it's 0.5 millimeter, that's fine. Okay, so a lever. So I have to be able to turn this by hand. The previous lever, as shown in the other video, was about 2 inches long, but only on one side. I'm going to make it symmetric. I'm going to give it about, about the same, but I'm going to do it on both sides so I get a little bit more torque on there. So I'm going to go sketch, select that bottom surface. Here the way to pan this around is I'm holding down the right mouse button. I can move it around. Now if I want to just translate it, I hit Control and right click, move it like that. But anyway, so let's go ahead and select bottom up here. All right, so a basic lever. So we'll create a couple circles first, and I'll kind of show you how I'm doing this. Bring it out here to this line. Let's make a circle. Let's make another circle over here. I can just kind of, let's make those equal. A little equal constraint. Select the first one. Select the second one. Let's dimension that. Let's do 6. All right. So now we're going to connect this to inner cylinder. So let's draw a little circle there. That's going to match that. Equal, so it matches. Okay, so now we've got another circle there I can connect those with. So I'm going to do line. And I don't even have to draw the lines next to them right now. I'm just close. Do that. Hit L again. Oh. Again, there's many ways to do this. This is just a very basic way you can illustrate some function. Obviously, those are not touching. So what we're going to do, we're going to go up to our tangent constraint. It will make the lines tangent to these circles. So select that, select the line, left click, select the circle. There we go. Same thing. I'm just going to keep doing that. Now we could have just done this on one side and used the mirror command. Again, there's always more than one way to do something in CAD. So you can see we've got these extra lines. We're going to go back up to our trim function. Trim that line. We're going to trim that inner arc. Trim this inner circle, part of it anyway. Zoom in. Get rid of that little angle there. There we go. So, got a dimension there. We need a dimension for the overall length. Let's just do center to center. It's already symmetric. Let's do about let's do 55. Nope. So maybe we did not do the symmetric. So let's do symmetric. Select those two circles. There we go. Much better. Okay. So complete that sketch. You can see now we've got our lever arm there. Sketch anyway. Let's make it solid. Extrude. Select sketch 4. Now we do not want it, I don't really want it an inch tall. Let's make it about 18. There we go. Okay. There you go. You can see this is taking shape pretty nicely. All right, so now we need to add a counterbore because there is a little fastener that's going to go through this outer side down into there. And you can see, you know, the whole time I'm thinking about this, I'm thinking about 3D printing. How's this gonna print on my print bed? So this would be my bottom surface is what I'm envisioning. And trying to minimize the use of any support materials. I don't really want a lot of overhangs. I want it to be simple and I just want it to work. All right, so let's go ahead and create our counterbore here on the bottom. Got my center. Made my circle. Let's just do that. 5. Let's do 5.5. Okay. Obviously, this is dependent on the fastener head diameter. All right, so let's see. Let's go ahead and select that. Let's do remove. Select my sketch. Okay, now it's going a little too deep there, because it's getting past. I need a little wall between the lever assembly and the vacuum sealer shaft, so that fastener has something to actually fasten it to. Anyway, so the way we're going to do this is we're going to go up to face. We're going to select this bottom face. That will give us some thickness between the counterbore and this surface. You can already see it kind of gave us a preview there. Okay, there we go. So that screw is going to go down, it's going to rest on there, it's going to go through, and it's going to attach to the vacuum sealer actuation shaft. All right, so it looks okay. I'm going to add a fillet to this transition, kind of try to reduce some stress concentrations there. So let's do that. Select that edge. There we go. That's just 1 millimeter. Let's look what 2 millimeters looks like. Yeah, it's not bad. You can make it look a little fancier, but right now I need to use my food sealer. So I just want something that works. Okay, so that really wraps up the design phase. Pretty simple. Onshape is very simple to use, in my opinion. You know, I've been using CAD for a while, but it's very intuitive. It gives you a lot of tips. So in the next video, you know, we're going to take this model into the slicer. We're going to adjust some settings there to kind of make it better for a functional part. We're going to 3D print it, and we're going to see how it holds up in the vacuum sealer. And after that, you know, I'll walk through any tweaks or adjustments I need to make after the first test fit too. I don't anticipate needing any. I feel like I measured everything pretty good, but you never know. There are some tolerances on the 3D printer, but I think it should be able to handle this. So if you're into practical CAD and prototyping, make sure to hit that subscribe button and follow along. Thanks for watching, and I will see you in the next one.